Okay, let's look at number 22 in section 5.8. We're going to evaluate this indefinite integral. And if you look at it in this section, we know we've been talking about integrals that evaluate as the inverse sine or inverse tangent, for example. And this one certainly looks to be close to being inverse sine, but we need this 49 to be what? To be a 1. And so that's our first goal. The way we're going to do that is we're going to factor a 49 out of this expression under the radical. Again, how can I do that how can I factor a 49 out of 9x squared? Well, easy. I pull 49 out of 49, leaving 1, and a 49 pulled out of 9x squared leaves 9 49ths x squared, right? If I multiply this back through, I will get 9x squared. I can break this radical. The radical of x times, or u times v rather, would be the radical u times radical v, where u is 49 and v is this stuff. Square root of 49 is just 7. So I can pull that out as 1/7. And then I want this to be my u squared now. So u squared will be 9 49ths x squared, meaning u is what? The square root of this, which is 3/7 x. The derivative of u is just 3/7, so du is 3/7 dx. Solve for dx, I'll multiply both sides of this by 7/3. So I'll get 7/3 du is dx. Okay, so again, that 1/7 comes out. The dx is 7/3 du. Square root of 1 minus, right, this becomes the, right, rather that becomes the u squared. Now pull this 7/3 out, 1/7 times 7/3. Notice those sevens cancel. I just have 1/3, the integral of 1 over the square root of 1 minus u squared. And this is the form you should recognize as the arcsine or inverse sine function. So we'll write it this way. All right, 1/3 inverse sine of u. And remember, u was 3/7 x. And so replacing u with 3/7 x gives me this. And here is my expression for the antiderivative. And again, don't forget your plus c. Okay. Hope these are making sense in this section. Let me know if you have questions.